The only problem with what I told you yesterday is the graphs can pass through an oblique asymptote near the origin. In the ends of the graph, it never passes through. And it can also pass through a horizontal asymptote. So that's really the only difference, and that's just going to make us do a few extra calculations. So let's see if we understand the idea. So if I had, let's say, a vertical asymptote there, and I had a root, and then I had another vertical asymptote, and that's a single root. So it's not a double root, it's not a bounce-off root, it's a pass-through root. And then I had a horizontal asymptote. You can pass through a horizontal asymptote as long as it's near the center. On the edges, way out there near infinity, you can't. So if you plugged in the numbers and you got positive, you have to plug this in. So negative, positive, and positive, the graph would look like this. So you can pass through that horizontal asymptote. Okay? So let's work one. Okay, well, we're going to do some in your book, but let's do one that I make up first. Okay, does this one have a horizontal asymptote? Yes, at not 0, 1. Why 1? Because the degree of the top is equal to the degree of the bottom, so we take the leading coefficients, which are both 1s. So it's 1 divided by 1, which is 1. So my HA is y equals 1. Okay? So let's factor the top and the bottom. So x minus 3, x plus 3 over x minus 5 times x minus 2. Do I have any holes? No. Do I have any vertical asymptotes? So my vertical asymptotes are 5 and 2. Do I have any roots? Well, when does the graph equal 0? Whenever the top equals 0. So my roots would be x equals 3 and negative 3. So I draw my graph, and I have an HA at y equals 1. I have a VA at 2. And I have roots at 3 and at negative 3. Oh, I also have another 1, 2, 3, 4, 5. Okay. So on my x-axis, I have these critical points. And that's what we call them in math, is critical points. Those are the points at which things change. All right? So, well, I guess I can use that calculator. So I need to test over here on the left side. What number should I plug in? Negative 4. I want it to be as small as possible, and whole numbers are usually easier. So I want to plug in negative 4. What am I looking for? Not positive or negative in this case. Bigger than 1 or smaller than 1. I want to know, do I graph above the horizontal asymptote or below the horizontal asymptote? So I'm going to plug in negative 4. So I put negative 4 in here, and I get 16 minus 9 is 7. And then I get 16 minus, what is that? Plus 28 plus 10, which is 38, 48, 54. Is that bigger or smaller than 1? Smaller than 1. So this is a root. So it's going to go like that. And so now we have to test the other side of that root. Well, technically it could turn up. So it could look like this, because you can pass through that horizontal asymptote. So we have to double check everything. So I wouldn't do that. I'd plug in -2 would work. There's an easier number. 0 would work. Yeah, 0 is in the interval between those two critical points. So I plug in 0, and I get -9 over 10, which is negative. So it does look like this. So yesterday we just skipped around a lot, and we're not allowed to do that as much as I assumed. That's what you have. That's what you get when you take math from a bad teacher like me. Okay, so I need to now plug in something between these two critical points, between 2 and 3. So use your calculator. So 2.5 squared minus 9, I get -2.75 over 2.5 squared minus 7 times 2.5 plus 10. For the denominator, I get -1.25. So 2.75 divided by 1.25 is 2.2, which is bigger than 1. So I know that my graph is going to go like this and hit that. Now this one, can it, you don't understand what? So, well, the horizontal asymptote just tells you that where the ends go. In between the ends, it can pass through that horizontal asymptote. But this is saying, if you go way out here to the right, it's going to get closer and closer to this line. If you go way out there to the left, it's going to get closer and closer to that line. So in between the ends, it can pass through. Yeah. Which is weird, I know, but that's life, I guess. Okay. So now I need to plug in 3. No, 3 is a root. 4. So 4 squared minus 9 is 7. And 4 squared minus 28 plus 10 is -2. So 7 over -2 is less than 1, so it's below the horizontal asymptote, so it looks like this. Okay? Which, that one we did know because it was a single root, so it had to pass through. If we know that it's up on one side, it would be down on the other side. And then my last critical point is 5, so I'm going to plug in 6. So 6 squared minus 9 is 27 over 6 squared minus 7 times 6 plus 10 is 4. And 27 over 4 is, which is bigger than 1. So it's above the horizontal asymptote. So it would look like that. Okay. Does this one have any holes? No. If it had a hole, then we just go draw it where it belongs. And then we move on. So you guys want to see number 3 from your book? Okay. You guys are lucky. I only scheduled 3 days for this, but since I'm such a nice guy, because I'm a crappy teacher. Okay. guys thought Jackson was being mean to me. All right, number 3. So for number 3, we have an HA at 0 because the bottom is bigger than the top, and we have VAs at 4 and -4. So those are my 3 critical points. So I draw the graph. Oh, I also have a root, sorry. My root is 5. So my HA is the x-axis, and then at -4 and at +4 I have vertical asymptotes, and then I have a root over here at 5. Okay, and notice the root lies on the horizontal asymptote. Okay, well, that can happen. And I told you that that couldn't happen yesterday, and again, that's because I'm a crappy teacher. So, my critical points are -4, 4, and 5. So I need to plug in -5. And make sure when you plug in -5 in your calculator, you put it in parentheses. Because when you square a negative, it should be positive. If you forget the parentheses, it won't work. So, whenever you square it, -5 minus 5 is -10, and then parenthesis -5, parenthesis squared, minus 16 is 9, and -10 is negative, so we're below the horizontal asymptote. So the first part of the graph looks like this. All right? So for the next part, so if you plug in 0, what do you get? -5 and -16 is negative. Oh, sorry, positive. So it's positive. So that says everything between -4 and 4 is positive, which is above the horizontal asymptote. So what's the graph going to look like? Is there any way to approach both of these vertical asymptotes and remain positive the entire time? If it's a U shape. And it's not really a parabola, because parabolas are quadratic equations. It's just a U-shaped graph. Okay? And we know it's positive on both sides because there's no root between those two vertical asymptotes. Okay. Now, over here on the right side is the tricky part. So it is possible to pass through that. So what's going to happen is we might come up and through and then back down. Either that, or the other option is to start high and go through and then come back up and approach that asymptote. So either way, you're going to pass through the asymptote and change directions and then go back towards it. So what number do you want to plug in? I would rather plug in 6. Do I need to plug in 4.5? No, I really only have 2 choices, right? I have this one, or I have this one. And if I can figure out if it's above or below at 6, then I know where it is on the other side of 5, because it's a single root. And if it's a single root, it passes through. Double root, it would bounce off. So let's plug in 6. So 6 squared minus 9 is 27. And that's the bottom. And oh, sorry. I'm sorry. 6 squared minus 16, oops, is 20. So the bottom is 20. And the top is just 6 minus 5 is 1, which is positive. So at 6, we're above, which means at 4.5, we must be below. So the graph is going to start near the asymptote, go through 5, and then come back down and approach the x-axis. Say that again? It might. So you have to test both sides. Yeah. But this combination of vertical asymptote and root, single root, on one side it's got to be above and one side it's got to be below. Oh, because the root is on the horizontal asymptote? Okay, I see what you're saying. So if we had something like this, and then we had a root, and then we had like that. You test the critical points will let you know. So in this case, you have to test both of those critical points. And if it's on one side of the critical points, it will always be that. And if it's on the other side of the critical points, it will always be that. So you have to test this number and test this number, well, by testing these. So, great. So if it had no root, what's it going to look like? Come draw what you mean. Mm-hmm. I don't know that it ever would. I see what you're saying. So, yeah. I don't think that can happen. I think if it changes direction, it has to have a root. If it, so I don't think it could do that, but it could do this. Does that make sense? Yeah. But actually, the asymptote would be on the other side. But I think the only way for it to go through and then back up is if it crosses the x-axis. So if you run into one like that, let me know. But I don't think it can happen. Yeah. Me neither. Okay, so I'll give you the rest of today. Do you want to see any more? Do you want to think about that before you answer? You do want to see more? I can come help you. So let me turn this off.